Hello, everybody, and welcome to Meet the Author session. Today, we're going to talk about the evolution of overall networking with Victor Moreno. My name is Hilary Tiaga, and I am a community manager of the Cisco community and the host of today's event. So, first of all, we would like to thank all of you for joining us today. We know times are very complicated today, and things are not easy for many of us, but we actually kindly appreciate your assistance today and that you joining us today. So before we start, I would like to provide you more information about this session. Actually, in this session, the Cisco Press author and technical leader, Victor Moreno, will talk about the digitalization of work and how it has driven change and innovation through the entire IT stack. Along the session, Victor will be presenting key content from his featured book, from Network Evolution and Next Generation of Data Networks. At the beginning, as you can see here on the screen, we will know more about Victor. We will interview him to know more about his story and why he's joining and writing books. And then he will provide some key contents about his book. And at the end, we will clarify some of the questions that you have done to Victor live, right, on the Q&A panel or the chat panel. So before we start, I would like to share with you this very great news. This is a lucky winner that we have from a previous Meet the Authors event. This was the event that we hosted on February with Vinit Jain. His name is Ernesto Montiel, so he received his book signed by Vinit in this occasion, and he's actually from Mexico. It's not where I live, actually, but I live in Mexico, but he's just right there. He's very happy just getting his book. So today, actually, we have very great news for you because we are going to give away 2 free copies of the book that Victor is presenting today and sign it by him, okay? So to win this book, just please stay with us and be patient and pay attention to what we are going to say along this session. The first thing that we're going to talk about is, well, Victor, welcome to this event and thank you so much for being with us today.
Thanks, Hilda. Thanks for having me.
No worries. So let's know more about you. Victor, the truth is you are a very well-known expert in Cisco, and not only Cisco, also Cisco as well, on the IT, the networking, and the data networking industry. And that is not only because you are a Cisco Press author or a distinguished engineer, but also a very well-known speaker. So to know more about you, it could be a lot. I would like to ask you some questions, so let's start from the beginning. The first question is, how did you get into tech, Victor?
Well, I think it was an incidental thing more than anything. I did pursue a degree in engineering, but that was more out of peer pressure. And then I started in a support role with Digital Equipment Corporation, and then that evolved into a teaching role very quickly. This was done in South America, and all that teaching was a forcing function to learn a lot about networking. We were basically setting up data centers all around Latin America, and that knowledge of networking basically led to an involvement with Cisco, and it's been about 20 years since that involvement with Cisco. Before that, there were about 5 or 6 years between DEC and Microsoft. Yeah, at first it was more curiosity than anything. I didn't think it would be a long-term endeavor. The more I dove into networking, the more I found it interesting, and I was just intrigued by how do we actually get all this information from one place to the next. And you'll see that I've been double-clicking into that more than you normally would expect. But yeah, it became a lifelong passion. It wasn't something I grew up thinking that I would do. It wasn't planned either. So it happened organically. Opportunities presented themselves one after the next.
Awesome. It's actually quite funny because I usually ask people like you, like, was that your passion? Was that your major? Was a special opportunity, a family promise? And I'm so glad you actually covered that right? And the thing is like, okay, like it happened by curiosity and actually very spontaneously, but is there like a particular reason why once you started to be in IT that you decided to choose this specific career path?
Well, it was always intriguing to see if we could do things better, right? And because of the background in creating a curriculum and trying to simplify things to communicate them to people, you start diving into things in a lot of detail, and that just basically presented a very clear view of things could be done in a much simpler way. Why do we have 5 different ways of doing the same thing? Why do we connect things in a certain way? So that started showing a clear view of, well, I think we could make a difference here and simplify all of this, and maybe when we teach our classes, it would be a lot easier. You know, the irony in that is that things have gotten simpler in some areas, but also richer, and they've actually evolved to include more and more functionality and more moving parts. But the choice in terms of the career path was just basically a clear opportunity in terms of being able to simplify things. And you got to also keep in mind that networking, 30 years ago, networking was somewhat undefined. It was being invented, if you may. I remember going on tours with some of our data center leaders, and us basically saying, well, are you prepared? Yes, I'm prepared because I invented this, right? So there's nothing that you wouldn't expect. And that was 30 years ago. Today, we go against a very different audience, right? Today, people are educated. The basic principles of networking are very well understood, and whatever worked and whatever didn't work has actually been weeded out. But there was a clear path to participating in what was evolving at that point. So it was a mix of finding an interesting subject where questions were not fully answered, and riding that wave where things were actually being put in place and answered right at that time. I think today that the opportunities are there very much, but in other areas. So some of the foundation has been set, it's cemented, it's well understood. Then the question is, how do we take things beyond that, right? And that's what keeps it going, right? So it's a never-ending endeavor of innovation and change, and I think that's what shaped the interest, right? I guess later on, the fact that there was all this opportunity actually allows you to look at the different opportunities you may have within the industry and fine-tune your goals and your aspirations to participate in teams that are actually creating the technology. So for me, Cisco was that place where you had the canvas that you could use to draw new technology. There were many opportunities along the way to go and operate networks, and that would be more of a user view of things, and that's extremely valuable experience as well. I had already done that for a while with Tech and Microsoft, so I think the career choice was to stay within the development part of the IT industry.
Well, thank you very much, Victor, and you are totally right. Things continuously change, and innovation is going and going, and even like, for instance, like the Cisco certifications, they just recently changed at the end of February, right? And everything is going all the way. So connecting to everything that you have been mentioning, do you have any recommendation for those who are seeking to develop a career in networking, considering all these changes and all what's happening and your experience?
Well, so I'd say stay alert, be patient, don't run in haste pursuing a fad. It's a little bit like the stock market. There is a continuum of progress, but there will be noise along the way. So there will be some temporary trends, and you will notice the industry realign to some of those trends, and then come back to what is actually workable. Just stay your course and understand that the key objective is to actually deliver services, and there are some core tenets to delivering those services. So as long as you stay focused on those, there will be fads and trends and things, but there is a core to the whole evolution of IT that keeps us going. So you don't need to chase every single thing that is introduced in the industry. Understand the core principles, build your own criteria, be your own critic, and that would give you clarity in terms of which technologies are actually things that can be pursued. So that would be one thing. Just stick to the core principles so that you can create your own criteria. I think is the key thing that helped me along the way. Just keep clarity in terms of what was worth pursuing and what was just a temporary suggestion. Right.
Great. Thank you so much, Victor. And well, as you mentioned before, you have been working with Cisco for around 2 decades now, well, more than 2 decades, and you have collaborated in the creation of different content and technology enhancements, like development, as you mentioned. So we would like to ask you a couple of questions about your career path and things more related to this book. So what has been your motivation to write this book or any other kind of content?
Oh, okay. So in that quest for foundational tenets that would actually guide us through evaluating technology, I've been very fortunate to meet some extremely influential and smart people along the way at Cisco. So I started working in the tech, then went into the product teams quickly after, and then within the product teams, we started looking at certain problems and started finding different ways of doing things. And it's not always the well understood way that actually solves the problem, right? And I'll talk a little bit more about that when we talk about the evolution of overlays. But we get to a point as a maturing industry where there are technologies that are well understood. So take IP routing, for example. And IP routing has a series of elements, and some of the elements are basically focused around transmission of information. Other elements are around the processing of that information to calculate better routes and so forth. Now, the key thing to understand is that there is a very specific mission to that, and we tend to reapply that technology to other areas as we are presented with new problems, right? One of the things that has been interesting is as we get new problems, there are new ways of doing things and addressing those problems, and we don't need to carry forward a lot of the functionality that we had gone familiar with. And it is in that reset of frameworks and ways of thinking that documentation becomes critical. Documentation and communication becomes paramount. And that's part of the motivation for this book and other publications. Unfortunately, I haven't had enough time and bandwidth to do more of it. But frankly, when we introduce something like Lisp to the industry, we've found ourselves up against a lot of questions around, well, what is it that you're suggesting? Is this an alternative to routing protocols? And the answer is no, by far no. And it's been labor of love in educating people in terms of what is it that this protocol brings to the table, how it solves things differently, and why we would want to actually add this to the arsenal of things that we use. So educating and basically driving that mission, having people understand why we're thinking the way we're thinking has been the motivation behind writing a lot of these books and papers. It's been a journey in trying to, some people say, well, you're trying to change the industry, and it's like Sisyphus trying to push that rock up the hill. And it's not quite that. We're trying to basically expand the horizons of industry. And ironically, if it comes from within the networking ranks, it's very difficult. But if you look at what's being proposed in Lisp, it's very much in line with where the cloud providers and the cloud services and cluster management systems ended up with their networking paradigm. So in a way, it's setting the ground of what the industry may do, and you never know where things are going to get adopted, right? It may get adopted from the perspective of the networking industry, or it could be adopted in the server stacks, right? So that's been a lot of fun, and it takes a lot of communication and a lot of thinking about how do I make things simpler, but also how do I explain these concepts in a simple way. If you think about it, the book, the Lisp book that we put out is unusually short. I think it's just shy of 200 pages, right? And it was very interesting to have the exchange with our publisher, and Brett was gracious enough to entertain the fact that we wanted to do something that was very concise. So many motivations, right? Can I explain technology to my grandma is also one of them. Right?
That's great. That's really awesome, Victor. And I like the fact that you share what was exciting actually, and what's something that you really found interesting through all this way. And actually, related to that is like, I would like to ask, like, when you were preparing the content, or let's say the whole material for this book, what topics, the evolution of next generation of data networking book in particular, what topics you have found most interesting, exciting, or challenging?
Well, we found many things, and by the way, I co-authored this book with Dino Farinacci, who's been a mentor all along this journey of changing the industry and introducing innovation into the industry. For those of you that don't know Dino, Dino's invented things that you probably use every day in your networks, ranging from how GRE is defined, a lot of the work in EIGRP, and most of the multicast definition, all the MIB definitions, etc. So we've had an opportunity to actually collaborate in inserting all this change to a level that is, I would say, it's pretty unique from my perspective. And sorry, you asked a different question. I wanted to make sure that we talked about Dino and.
Yeah. That's fine. So it's just like more or less about what topics you found more exciting or challenging.
Yeah. So in that journey with Dino, we've been challenged to do many things, right? And in the early days, it was pretty straightforward. VMware was introducing vMotion, and we wanted to exchange data between data centers and make sure that you could move a host between data centers. And those were the early days of mobility, right? And we thought that was super exciting at the time. Fast forward only a few years, and now we're looking at basically launching low Earth orbit satellites and having hundreds of them orbiting the Earth, and creating a network where the nodes are now mobile. So the topology itself keeps reorganizing itself as these nodes actually orbit around Earth. And we use Lisp to actually create the communication mesh amongst all of those satellites and the base stations on planet Earth. And you can see now how instead of the devices being mobile, the network has become mobile. So that's a pretty exciting environment, and it's pretty mind-boggling to actually try and visualize how that mesh actually changes as the satellites move around. So that's been exciting. We've also been working with the aviation regulators and being able to provide very large-scale solutions for them, and being able to now have all your planes IP connected and streamlined, basically digitize the civil aviation operations. That's been extremely exciting. We are currently looking at ways to actually help provide a fully private environment where we can do contact tracing for us to help with the identification of contact or exposure to the coronavirus. And we use the technology in that vein too, running on cell phones. We've also had the opportunity to create very, very dense mobile environments where it almost looks like a scene from Blade Runner, where you have the different vehicles at different layers just moving around, and we're able to network all of this and to actually keep track of this in real time, right? And we've been able to feed some of what we've learned there in terms of the testing stimuli and the parameters that we care about and the speed at which we need to run the updates. We've been able to feed that as reference material to the bodies developing, to 3GPP and the bodies developing all the mobility framework for 5G and beyond. So all of those things, mostly around mobility and preserving connectivity and that mobility, have been a critical or a very, very rewarding part of what we do. So those are the fun projects, and of course we have all the applicability of all those findings into our more everyday networks, right? But if you take that in a graded way, you could take those very dense environments where there's much mobility, and you make them a little less dense. So you go from a warehouse to a city, and now you're looking at networking cities and dealing with connected vehicles and the whole IoT gamut of devices. And slowly but surely, that starts looking a bit like a more dense version of a university, and then we go into higher ed. So you can see how all of these principles actually trickle out into your regular enterprise, right? And it's been very rewarding to study it in the extreme cases, and then bring all that know-how into the more practical and common environments, right? So all of those things, those sophisticated things that we've learned with satellites, with high-density robots moving around, with very, very fast convergence requirements, all of that we've learned, we've actually used to study how we connect the billions of things that we're trying to connect to the network in our everyday life, in our universities, in our campus, in stadiums, concert halls, and so forth, right? So that's given us the opportunity to better understand, well, could I just continue to use my routing protocols for some of these things, or could I do things differently and understand with a better understanding of the problem, right? Because we know from these experiments where we could end up. We know from these experiments the type of pressure that we would be putting on the network and the control plane and the management plane of that network. And it's not evident when you are basically filling up an RFC or a request for proposals for a customer. Well, the view tends to be a 4 or 5 year view, but the problem could actually exacerbate, right? So that's been very rewarding and very interesting. And Dino's been my co-conspirator on all of this, and he's brought in extremely interesting use cases over the years, and that's actually pushed the envelope of how we approach these problems.
That's great, Victor, and thank you so much for acknowledging Dino. And yes, indeed, I'm not an engineer, but I have been learning a lot from you and people like Dino, so thank you so much for calling this out. And finally, just before we start with your presentation, is who will be the target audience for your locator ID separation protocol book?
So I think the book appeals to a very broad range of people. We tried to write the book so that it could benefit architects for sure, people who are tasked with evaluating different technologies, people who are tasked with solving problems in their daily jobs and making decisions on technology choices. So we're trying to give you a view of the different use cases that you may encounter. We're trying to give you a view of how these use cases could be solved with networking technology and what are the things to look out for. So trying to create those tools in your arsenal so you can evaluate different solutions from the lens of understanding what are the things that are challenging when you develop technology to solve those problems. So scale, convergence speed, extensibility of the protocol, not having to proliferate a series of different mechanisms and different heuristics to add services. So those are the type of things that we were actually hoping to educate people on. But also, the book should be consumable by people who are at a higher level, who are more focused on business and who want to understand, what are the kind of environments that this digital world is bringing to us, and why would I even have to worry about the type of protocols that I'm putting into that IT operation, right? And that one is a harder one to achieve because we're all engineers and we're all used to talking to engineers. But the intent was to also appeal to that crowd that was basically making the big decisions on overall corporate strategy and government strategy and so forth. And then it's actually served that purpose. We've handed the book over to a couple of people in the local governments as we've been doing this whole experiment on tracing, and we've also done that in other instances where it wasn't clear up front why you would actually have to worry about such a low-level consideration as the networking stack or the protocol stack that you use in the network. So hopefully that answers it. It's not a deployment guide. There is another good book that we kind of helped to review where there is troubleshooting and configuration for list networks. So you won't find a lot of configuration guidance, but you will find the concepts necessary to design a network. You will find the concepts necessary to understand why the technology is of relevance.
Okay, well, thank you so much, Victor, for sharing your story, experience, and all this knowledge. And well, now it's time for you for learning more about the evolution of overall networking with you. So I will give you the presenter's board, Victor. So
okay.
Yeah.
Yes.
And for all of you who have been posting the questions, please try to post them on the Q&A panel. It's easier for us to follow them up. And remember, Victor will be answering them at the end, okay?
Okay, so Victor time. Sounds like a beer commercial.
No beer today.
Yeah, no, and too early to. So let me share a little bit. I shared some tidbits of what my journey had been at Cisco and developing technologies, but here's a very strange diagram trying to portray what the journey has been, and if nothing else, understand that we have arrived to a point where the amount of functionality that we can deliver has increased exponentially in contrast with the levels of complexity that are required in the networking stack. And that's very rewarding to see, because we basically strived to do that, and you'll see some attempts along the way to get to that point. But that's been our ultimate goal. Can we actually make this, with an understanding of what matters, right? Can we make this simple enough so that you don't have 3 or 4 different protocols, and usually it's more than that, running in parallel to achieve a handful of services, right? So if you think of this over time, we start at a base requirement for segmentation, where historically we've created VLANs in the enterprise, and a lot of the motivation behind creating VLANs has been the articulation or the classification of our endpoints into subnets, and those subnets would usually be brought into a firewall, and then I could apply policies between those firewalls, and basically what we were doing was segmentation, right? And if you go back 20 years, people were using VLANs and steering traffic into firewalls, and if they weren't using VLANs, they were using separate network pockets. Like topological segmentation was very prevalent. And then it became evident that needed to be a little more flexible, and we went through creation of VLANs, a lot of layer 2 because of that, a lot of tears and blood from spanning tree loops and things of that nature, scale concerns, broadcast storms, and then people started thinking, well, maybe we could do the same thing, but do it at layer 3. And one way of doing that was using multi-protocol label switching. And basically what we were doing was creating the equivalent of a VLAN, which is a forwarding table with a series of ports associated with it. But we were associating the ports to a layer 3 forwarding instance. And then we would tag the traffic in a very specific way, but it was still MPLS and VPLS services were still very much done in the network, right? So if there was a convergence event, it would affect all the nodes involved and the nodes in between. And it also required that whoever was going to adopt this took a hard stance and made a strong decision to actually upgrade the entire network. So it's very hard to adopt. And when it was adopted, it worked very well. There's some complexity to an MPLS and a VPLS network that was an increase from VLANs for sure, but something that could be addressed. So we started seeing this trend in enterprises. For sure, service providers had been using it, but what came next was interesting. We started back in 2005, roughly. There was when we started designing networking specifically for data centers. Up until that point, switching was generic to data center or access. It didn't make a difference. But we started targeting the data center very specifically. And one of the things that came about was this whole notion of a wider use of virtual machines. And mobility was something that was very desirable for those virtual machines. So everything was layer 2 back then. We introduced Fabric Path, and we introduced Trill was the standards version of Fabric Path. And then VMware came out with their virtual switches, and in the midst of all of this, they counted on the network having certain VLANs be provisioned, and it was a little bit like the developer and operator's conundrum, where they were trying to use a network that wasn't necessarily pre-provisioned for them. So we, the network, Cisco, was in the way of whatever VMware was trying to do with their VMs and mobility of the VMs. In the interest of easing that, in the interest of scale and faster deployment of hosts, we created very large layer 2 networks, and we started connecting those layer 2 networks together with something we called OTV, Overlay Transfer Virtualization. So this is something that that Dino came up with, and I helped with a few ideas in it. But the main goal of this was originally to provide an alternative to the layer 3 segmentation that MPLS was providing, but to actually do it in a way that didn't require every node along the way to be a label switching node, that it could run over an IP stack, right? And it ended up being used for us to actually create layer 2 services instead. So we started connecting at layer 2 different data centers, and we would do it over an IP network. And back then, this is the early stages of our thinking. Back then, we defined two things. We defined a data plane protocol, which then became VXLAN. So if you look at the OTV specification, it is exactly what became VXLAN later on. And we defined a control plane protocol, and that control plane protocol was simply updating the location of the MAC addresses that were in one data center or another. So if a MAC address would show up, it would basically be advertised in the control plane protocol. That control plane protocol was basically ISIS. So talk about reusing something that we already had in place, right? And this was built in such a way that it was very, the way we productized it, we made it very specific to the use case, and we were able to actually give you an environment where with a handful of commands, it was about 3 or 4, you could actually create a connection between two data centers and now have what now AWS and Azure refer to as availability zones. Well, back then we had 2 data centers across the river, and we were basically connecting them with OTV. So we built into this a lot of loop prevention and backdoor connection detections, etc. But it was all built in for you in order to simplify complexity. However, we hadn't attacked the core of the issue, which was we were using a link state protocol for a function that was just a mapping function. So we were using ISIS and advertising MAC addresses across as if they were routes. But the reality is we knew what our topology was. We had 2 devices on the right, 2 devices on the left. You were either on the right side of the river or the left side of the river. And that's all we needed to know. We didn't really need to start calculating paths and all the stuff that ISIS was going to give us, right? So we basically, that was our first foray into this. But the key thing that we introduced here was we separated the overlay service, which was that layer 2 connectivity, from the underlay. So we no longer depended on the base network doing label switching like we did in the MPLS days. We had actually now made sure that the underlying network was simply an IP network, and we would write on top of that. And the VXLAN tunnels, or what became the VXLAN tunnels, which were the OTV tunnels originally, those were basically MAC and IP tunnels, right? And then the industry took on the idea, and they said, well, I like the OTV approach of the control protocol to simplify a lot of the layer 2 interconnectivity. So let's develop Ethernet VPN. And the reason it's called Ethernet VPN is because it was an address family that gave you the ability to carry layer 2 in BGP, right? And to create layer 2 VPNs over IP, right? So those are the 2 things that were introduced in EVPN. You could think of that as the early on, it was the standardization of what we had introduced with OTV. Now you can see how the complexity curve goes really, really high there. And the reason is we had to retrofit EVPN as an address family into the whole BGP machine. So there are tons of dependencies. You were still using BGP as it was. And this was eye-opening, right? Because with ISIS is designed to carry other address families, so it was pretty straightforward. We did have some extensions, but it wasn't anything major. But EVPN BGP wasn't designed to do this, and we also couldn't break whatever was already in BGP, right? So I would say that this was a function of the times, and then we understood, well, our task is not to do routing there. We don't really need to do routing. It's just an exchange of information to understand where the devices are located. The routing is actually done in the underlay, right? And that's, Lisp was being developed in parallel to this for other reasons, but what Lisp did was eventually just showed that I don't have to run a routing protocol as the control plane of that overlay, right? And that led to us basically reducing the complexity significantly, but also being able to extend what we were doing in that control plane so that we could have all the functionality that you needed in the network basically in one protocol stack with one set of operations. So if you think of it as how you would think of DNS, you could extend DNS to have all sorts of semantics and apply all sorts of policies to it and deliver a series of services that don't necessarily require DNS to change its base functional method, which is simply if I have a target that I need to communicate with, I will basically request a mapping from DNS, and DNS will get back to me with that mapping. Now, you could add conditions to that, and you could say, and once you get the mapping, you cache it, right? And then you forward according to what the DNS system told you, which is basically if I'm trying to get to cisco.com, it will give me an IP address, and that IP address could very well be the IP address of a load balancer. Or I could be directed, depending on where I'm at, I could be directed to a local proxy or all sorts of different things that you could do, right? But it doesn't, the fact that I go through a local proxy or that I use multicasting or that I may go directly to the server, whether I can connect at layer 2 or at layer 3, usually none of that alters the way in which DNS worked, right? DNS simply had a question and the answer was colored with the conditions. If I'm in a certain location, you're going to get one answer. If I'm in a different location, you get a different answer. Those type of things are built into policies that are going to allow this mechanism of request information and procure it at the time of connectivity. It's going to allow us to deliver services, right? So you see how the same principle is basically what you see in cloud networking. So when you look at container networking and you look at service meshes, there isn't a routing protocol running amongst the different nodes of the service mesh. Basically, every node is registering with a database, and that database is subject to a series of policies and rules. And when you need to connect to a particular node, you request information from the database at connection time with all the information about the connection you're trying to achieve, and you get a response that actually includes the policy to be applied. And the policy might very well be you will connect A to B, but you must go through a particular set of firewalls, right? Those are things that are very easy to do in a different type of protocol, but are very hard to do in a traditional protocol like ISIS or BGP for that matter. So that's basically been the journey into what we call intent-based networking today, and intent-based networking leverages a lot of that simplification of the protocol stack so that some of the policies that are expressed in the intent can be delivered in an easy way. Now, I've talked a lot, and I'm assuming a lot of knowledge, and all of this is explained in the book, by the way, but the thing that I want to make sure that we have clarity on as we leave today is this notion of overlay networks. Right? So what do we mean by that? So if you look at your network today, it's simply giving you connectivity from one host at the left end to the host on the far right. And in order to do that, you have a network topology, and you exchange a set of information amongst those. And those are your routing protocols as you know them today. In that set of information today is included the information about the host. So I'm going to have routes to get between the network devices. So I have a route to get from the switch on the far left to the switch on the far right. So if I want to ping from switch to switch, I can do that. But I'm also going to include in my routing updates the host routes. Yeah. So everything is built into the underlay network today. Now, if I was to separate that, when I use an underlay control plane, if it's layer 2, it's something like spanning tree. If it's layer 3, it's going to be the usual suspects of IGPs plus BGP. But if I was to actually create a virtual network and move those end hosts out of there, well, now my underlay network is tasked with focusing only on creating communication amongst the network devices. But the endpoints, the hosts, are no longer part of what that routing protocol, that underlay control plane, is taking care of. So the endpoints, the hosts, if you go back to the roots of Lisp, those endpoints and those stub networks that are connected to the internet core are basically where all the entropy is created and where the challenge is posed onto that underlay control plane, right? So before I did this, what happened was, if I go back, right, what happened was all the end hosts will connect in random ways, and I would use a little sliver of a /24 and a sliver of another network here, and I would end up with enough entropy that I had to create a ton of state in that underlay control plane. And what that meant was that the routing tables in those devices were growing significantly, right? So what Lisp was set to do originally was to ease the burden on the core internet routers by simply, and what we proposed was very simple. Just, well, create virtual networks and move the host state outside of the routing tables of the internet core routers, and now we can have a service over the top that would not be topologically bound, and that could therefore be summarized regardless of whatever entropy you had in the system. Right? So it had its own control plane. And the thing here, if you look carefully at this diagram, there isn't a topology to resolve in that circle that's at the top. And I'll pause so you take that in. There is no topological resolution that needs to be happening there, right? So a lot of what we discuss in the book is around this principle. Because of that, I can use a totally different type of protocol. I don't need timely updates on a link going up or down. I don't need to calculate multiple paths or best paths. I just need to map the hosts to the location where they are. And that's why Lisp is called the Location Identity Separation Protocol. The identity is that of the hosts, and we're going to be constantly mapping and remapping those hosts to their locations. Right? So that's the principle that we've been following there, and that's what's allowed us to evolve networking the way we have, because we've shedded all the heavy lifting that we needed to do in something like BGP, for example, where you have to calculate paths and you have to notify everybody. In Lisp, we only notify those who are involved in a connection. So if these two hosts are involved in a connection and something changes, well, it's only these two switches that are informed. So if you take a network where you have 200 nodes where you're connecting all of your hosts, well, you don't need to update everything. You only update the areas that are required to be updated. So that's one big part of the scaling profile that we achieve, being able to scope updates. The other big part is because I'm simply handling a database of registrations, I can register not just the endpoint information, but I can register other semantics about the endpoint. What is it? Where is it located? What's the time of day? Is it part of a group of restricted resources? And now I can start giving this all sorts of color. And when you look at that color, you will see that this lines up with the models that we use to actually create communication between compute nodes in cloud environments and so forth. So those are some of the base principles, and what we end up with is a virtual network, and the connection between those devices, of course, is just a tunnel. In the case of Lisp, it's an IP tunnel. You will find all sorts of different encapsulations in the industry. It seems to be normalizing towards VXLAN, but there's some talk about Genève out there, which is something that VMware and Microsoft proposed. But the encapsulation is the least of the problems. All these smarts are actually in that control plane, right? So we're looking more at a database-like concept where you register with that database, and then you can apply filters to the lookups that are executed on that database. And by applying those filters, you can provide the gamut of different features, right? So basically, the journey has been one between pull protocols and push protocols, with push protocols being your traditional routing protocols. And we talked about this. These are ideal for an underlay where there aren't a lot of changes, where you're actually making routing decisions. But it does require a fair amount of computation, right? And it does require a very broad distribution of information so that the network can converge the way it's supposed to converge, right? So if you combine that, which is proven, tested, we understand inside out, with an overlay where you are dealing with the more dynamic events where a device may plug into one part of the network but shortly after show up somewhere else, where you may want to insert a firewall in the communication between the two, where you may want to disallow communication between two devices. All of those things, right, don't need to be associated with the calculation of the path between two endpoints, right? So if you combine these two things, now you see that we've progressed from using one tool for everything to using the right tool for the two different tiers of functionality that we're looking at using as we evolve the network. And many of the things that we have traditionally done in the network, we can move into the upper tier. Of course, not the routing and the multipathing, but when it comes to providing a layer 2 service or a layer 3 service for VPNs, when it comes to providing a multicast service, when it comes to providing a cryptography service where you can do pairwise crypto negotiation. All of those things can actually be moved into a database approach that scales better, where I have scoped updates, where I'm not updating all the infrastructure, and get basically the best of both worlds. And this is what you will see a lot of in the modern approaches of the network. Okay. So I'm going to pause now. I've talked a lot about this, but at least this is the foundation of what you will find in this book, and you'll find a lot of use cases are built around this and how we've addressed them, and how this simple principle of separation of duties is actually effective in giving us better scale solutions and solutions that are more effective and more malleable for these different use cases. So I don't know, Hilda, if there are any questions that bubbled up that you would like to discuss, or how we're doing for time.
Hi, Victor. Yes, unfortunately, we don't have too much time, and actually, we might cover these questions later on. And we are going to create an FAQ document with all the questions and answers. But I would like to take the time just to address one question, Victor. The question will be, in which networking area have you felt most comfortable? Switching, routing, or virtualization?
Great question. I think all three are part of the same tribe. That said, I think my focus has been on applying routing to create these virtual services. So that's probably where I've been the most comfortable. Um, Switching was my root, for sure, and understanding the subtleties and things that worked well and didn't work well in switching actually gave me a very solid foundation to look into protocols and how we could best do things there. Um, so yeah, I guess routing and virtualization would be the comfort zone, but we need to know all of them.
Okay, I'm going to cover one last question, and then we are going with the winner. And sorry for taking more of your time, people, just very few minutes, okay? So how next generation of data networks converge with CDN providers in the delivery of video to all?
Is that a question for me? Oh, okay.
Yeah, that's the question for you.
I thought that was the question to win the book. So content delivery providers are basically at the heart of this whole notion of connecting users to information. And for us, the task has been, can I give you a scalable way of connecting to those services? And if the services have specific requirements, so say it's a multicast service, or you need to connect at layer 2, or there's any of those changes, then the front end or the last mile from the user to the service would benefit from these pool type mechanisms. If you're uploading to the CDN, that's also the case. The CDN itself, we've done a lot of work with content providers in terms of how they handle multiple subscriptions and very broad multicast broadcast streams. So we also enabled the CDN network itself for the distribution. So it plays in both areas.
Awesome. And Victor, one final question is, why to use the locator ID separation protocol and not going down the path as industry vendors pushing eVPN as a control plane for VXLAN?
Oh, so I've worked on both, right? And hopefully I made a clear case on why we evolved into Lisp and not stayed on the VPN front. We offer both. The key is with the pull paradigm, we can do things that we can't really do with the push paradigm. And even if the push paradigm can emulate that behavior, we found that scale basically stops at a very early stage. That early stage could be sufficient in many cases, though, for now. The question is, how long do you hold that fort? And do you continue to pay the price of the complexity that creates? So those are some of the considerations, basically: simplification, scale, performance, and extensibility. Those are some of the reasons why we use Lisp. And by the way, Lisp is a full standard. Adoption of vendors, that's a different question, although there are implementations in place. But it is fully standard. There is nothing proprietary in the Lisp stack. That's all disclosed in the IETF. There's no intellectual property rights for the base specification and the foundational elements. So technically, it is a standard.
Okay, awesome. Thank you so much, Victor. And due to the time, we will not be covering any more of the questions. I repeat, we will be creating a document, an FAQ document with all the questions that they have been asking you. So I will contact you later on, Victor. And now, well, just to not take any more of your time, first of all, thank you for your time, Victor, and for sharing everything with us. It's great to have the chance to collaborate with someone like you. And also, well, for all of you, we have some extra resources and references that can be useful for you with all these changes and movements that Victor has been mentioning, including the link to access to Victor's publications and his participation and trainings in other events like Cisco Live Europe. So you will find the link on the chat. available, and also on this presentation, which will be available as well as the recording in the event page where you just register. And well, it's time to congratulate the winners. Remember, you have to be a community member to be a winner, and also you have to fill out the survey. If you don't fill out the survey, we cannot give you the prize, okay? So the winners are, first of all, pardon me if I don't pronounce your last name properly, Osita Nayokubi. Sita, you are one of the winners of this book, so we will be contacting you, one of our community representatives, via email. So thank you so much to the email that you used to register to this event. And the other one, I'm kind of like surprised. We select them through random decision. And the other one is Luis Cordova, which is actually a top contributor from the Spanish community, and I just can't believe it. But Luis, you are the winner of one of these books, so thank you so much. Remember, if you don't fill out the survey, you won't get, and you won't receive this prize. But well, for all of you that didn't got the chance to win this signed book, we have a great news for you. We talked with the Cisco Press, and well, we can offer you a 40% discount. We have a special code that has been just created for this event. I have just pasted in the chat, so you can use this code. Remember, you have to fill out the survey to get a 40% discount to get Victor's book or any other educational material you're looking for. I repeat, like the details are just in the chat, so feel free to copy them. And once again, thank you so much, Victor. Thank you so much to all the team back in the community. As you know, we have a lot of people behind the scenes that help us to make this possible, and thank you so much for your time. Please help to complete the survey. Help us out to identify how we're doing and how can we do better. Okay. Well, thank you for joining today. We wish you are well. We hope to see you in the next session, and please stay well, safe, and healthy. Thanks, Victor. Have a great day.
Thanks. Bye. Likewise.